Welcome to the Crazy Hat Chemist. So today we're doing another video on bonding and Lewis structures. So here we go. Bam! So Lewis structures number 8. We're going to be drawing the Lewis dot structure for sulfur tetrafluoride. Again, we need to come up with the formula for this. Hopefully you remember way back from your nomenclature unit. This is two nonmetals. That's a binary nonmetal compound with prefix naming. That tetra is the prefix naming. That tetra tells you how many fluorines there are. That's 4 for tetra. So sulfur, there are no prefixes on the sulfur, therefore there's only 1. Fluorine, there are 4, so it's sulfur tetrafluoride, which is SF4. Next thing we're going to do is we're going to look on our periodic table right back behind me there. We're going to find out how many valence electrons for each element. Sulfur is 6, fluorine is 7. There are a total of 4 fluorines. We're going to sum these numbers up. That gets us 34 total electrons. We're going to divide this by 2, and then that will give me 17 pairs. Then the next thing to do is find the least electronegative and place that element that's least electronegative, that is the one that's furthest from fluorine, that goes in the middle. So, there we go. That sulfur is the least electronegative, it goes in the middle. Then the other elements surround that sulfur. So, the other elements surround the sulfur and the X marks the spot pattern. The next thing we're going to do is place a pair of electrons between the central element and the outside elements, forming a single or a sigma bond. I have done that just there. Next thing we do is we place a pair of pairs of lone pairs of electrons around the outside atoms as lone pairs of electrons. I've done that there. I've actually used up 16 pairs of electrons. I have one more pair of electrons to do. So now the next rule is to place a lone pair of electrons and dump them all in the central element. And if you notice, the sulfur already has an octet, but sulfur is in what period? It's in period 3. So because sulfur is in period 3, it can exceed the octet rule. So that's why I'm able to dump the last lone pair of electrons directly in the sulfur. I'm going to verify the octet rule for the fluorines, and the octet rule is verified for the fluorines. Then the next thing I'm going to do is I'm going to write out this Lewis dot structure so it looks nice and pretty. That is, single bonds between the central element and the outside element are lines. Lone pairs of electrons, whether they are on the outside elements as the fluorine or that purple lone pair of electrons that is a non-bonding pair of electrons, are represented as dots. And then we have our final Lewis dot structure. You should see that there's a lone pair of electrons on the sulfur. It is exceeding the octet rule, but the fluorines, they all have an octet, which is perfectly acceptable. I am the Crazy Hat Chemist. That was another video. Give me a thumbs up if you like that video. Subscribe to my YouTube channel, and I'll see you next time. Bye now.